Hello, this is Lecture 2 from Chapter 10 of Actuarial Mathematics for Life Contingent Models. In this lecture, we're going to take on very challenging exercise 10.7 from the Pension Mathematics chapter. First, the setup for this question is long and arduous, but let's concentrate just on the paragraph at the top. So a new company, employee is 25, and her company offers a choice between defined benefit and defined contribution plans. Her salary right now is $50,000 per year, and salaries are assumed to increase at a rate of 5% per year. And we'll assume they increase at year end. Okay, and under the defined benefit plan, her final pension, this is a typical way to calculate a defined benefit pension, is 1.6% of her final salary times the number of years of service. Okay, and the normal retirement age is 65, and the pension's payable monthly in advance. Okay, under the defined contribution plan, the company's not promising anything except to deposit 12% of the employee's salary into her account each year. Okay, and then we have various questions here. I'm going to start off question A just so we have a chance to look at some of the information here. For question A, to calculate her projected annual rate of pension at age 65, we didn't know her salary at age 65, so let's just calculate that on this page so we can see a couple of the numbers at work. So her salary at age 25, we're told, is $50,000. And then her final year of salary will actually be her salary at age 64. And that's going to be her current salary, $50,000, times 1.05 to the 39th. And when I do that calculation, we get that her salary at age 64 will be $335,000 and $335,238. Sounds like a nice ending salary. Okay, so we'll use that on this page to actually calculate the pension. The pension at that time, the annual rate of pension, will be, we said 1.6%, so 0.016, times number of years of service, that was 40, if he works 25 through 64, times the final year's salary, which we just calculated was $335,238. And if you do that calculation, you get an annual pension of $214,552. $214,552. Okay, that's part A. Part B is a little more complex. It's to calculate the company's contribution, still defined benefit, as a percentage of her starting salary for the first year. And we assume no exits except mortality, and we're told the probability that she'll be around at age 65. And using the projected unit credit method, we'll assume the salary increase, and the contribution we need to make is the entire amount of the reserve for that. And her pension that we're responsible for after 1 year of service is going to be discounted 40 years. If we deposit it now, we're going to be responsible 40 years from now for this amount, times the probability she survives those 40 years, 40p25, times 1.6%, 0.016, times 1 year of service, times what we expect her final projected salary to be, $335,238. Okay, and if you do the math to work that out, you get that the contribution should be $4,589 this year, but we were asked to find that as a percentage of her starting salary. So that percentage should be that 4,589 divided by 50,000. Okay, and you can probably do that even without a calculator. That's 9.178%. Okay, so in the first year, the company expects to contribute 9.178%, or will contribute that amount. Okay, and now we turn instead to the defined contribution plan. The employee decides, well, I'd rather just have the money in my account and let it accrue at the rate it will. And we're told contributions will accrue at a rate of 8% per year. And we're going to assume that the monthly annuity factor for a 65-year-old is 11. And we're going to assume the employee stays in employment, so we don't have to worry about survivorship. And we want to calculate the projected fund in the account at age 65. And this is actually a little tricky. the contribution for year T is equal to 12% of the salary in year T. So 12% of 1.05 to the T, perhaps I should be using K's here since everything's an integer, times 50,000. Okay, so that's the contribution, and the accumulated value with interest at age 40 is going to look like this. That first year's contribution, 0.12 times 50,000, is going to accumulate for 39 and a half years. She's contributing salary throughout the year, so to simplify our calculations, we'll assume the entire 12% is deposited mid-year. Okay, a common assumption. Okay, and then the next year's accumulation, the next year's deposit contribution will be 12% of 50,000 times 1.05 because the salary is increased, but things are going to accumulate for one fewer years, 1.08 to the 38.5. Okay, and so on. Okay, so if we form a sum, how this looks, 0.12 times 50,000, 12% of 50,000 is half of 12% of 100,000, so that's 6,000. Times the sum is k goes from 0 to 39, and now we want to write this carefully. It's of 1.08 to the 39.5 when k equals 0, down to 0.5 when k equals 39. So 39.5 minus k times 1.05 to account for these salary increases to the k. Okay, so this looks like it's hard to calculate, but if you look here, if we pull out 1.08 to the 39.5, we get a single fraction here. So this is 6,000 times 1.08 to the 39.5 times the sum as k goes from 0 to 39 of 1.05 over 1.08 to the k. And we can write this out as a term that becomes an annuity. This is just equal to, if we multiply these things out front, it's equal to 125,427. Okay, times the sum as k goes from 0 to 39 of 1 over 1.02857 to the k. And that's just 125,427 times an annuity lasting 40 years, an annuity certain, lasting 40 years at this interest rate, 0.02857. And we can calculate that number. The amount in the account, so this is the answer to number 1, is equal to 3,052,123. And that sounds like a great deal of money. We'll do part 2 on the next page. I'll add a page here. On this page, so for part 2, that amount of money that we have set aside, $3,052,213, has to provide an annuity, and this will be an annualized annuity rate. So we would divide by 12 to get the monthly annuity, times an annuity due monthly for a 65-year-old. Okay, solve this guy for P. P is 3,052,213 divided by that annuity amount, which we're told is 11. And we get $277,466 per year. Okay, and 1/12 of that amount per month. All right. D and E, after that hard question, they become a lot easier. So it says, D says, explain briefly why the employee might choose the defined benefit plan even though the projected pension is smaller. So for D, it's very simple. The company carries the risk. Company carries investment risk. And survivorship risk, for that matter, carries investment risk. So that means if the funds don't earn the expected interest rate, the company has to make up the loss. Whereas under the defined contribution plan, the company's just depositing the money, and the employee is responsible if the funds fall short. The employee just has a smaller pension or has to make it up with savings. Okay? So E has the same answer as D. And those are quick answers. And this has been Lecture 2 on Exercise 10.7 from Chapter 10 of Actuarial Mathematics for Life Contingent Risks.